Hey, I'm Alpha. Welcome to another Liblast development update. In this short video, I want to show you what I've been working on recently. One of the things are the new faces for the characters. And they're somewhat interactive now. So I've had fun designing some expressions. Let me... Yep, so the faces are one thing. Another thing is the character outlines. It may seem natural and fine, but it was really difficult to get to that point, so the outlines look like they do now. And yeah, maybe I'll show you out how does the face thing work. So what I've done is I've designed a special sprite sheet. This one is 4x2 frames or cells. And the first one is the default neutral, you may say, face. It looks quite unhinged, and that's on purpose. All of them I have some ideas on what they will do in game. There's also a blank spot still. And if we get more, I can always expand and make this trim sprite sheet bigger. That's not an issue. What was difficult for me to do, but I figured it out, was getting these faces into the game using a shader, because I could use a sprite 3D like I'm doing for the status and the badge, because the status, also I've added a new status icon and rearrange these. The status, the Sprite 3D node, which I'm using here, has this awesome thing that you can specify how many frames of animation it has, horizontally and vertically, and then just switch between the frames, right? So this is pretty much what I needed to do. I need to do this in Visual Shader. Of course, the Sprite 2D has the Sprite 3D has also a a special region editor, and yeah, none of that is required for my work with the face. But the face, so the face has a visual shader, and this is the shader so far. So here we are getting the face expression texture, which is a sprite sheet, as I've shown you before. And this is exposing a sampler. So I'm putting that sampler here, and we're providing UV coordinates. So now the thing is, how do we get from basically this, because this is what happens when you just load the texture in. How do we show one of these faces, and how do we access each one with a single index number? So that took some thinking and experimentation. I was thinking about maybe implementing this using nodes, but then I thought, no, let's do this in an expression. So there is this one expression node which takes care of all the difficult parts, which is it takes the amount of frames or cells horizontally and vertically. So I input 4x2 because that's the dimensions that my sprite sheet has, 4x2. So this is one of the inputs. I call it cells. So cells.x is how many cells there are in horizontally, and cells.y is how many cells are vertically. I also feed the number that represents which expression I'm trying to pick, and also input UV coordinates, which is the UVs that just span the whole thing, which is the defaults that would show us the entire thing, which is something we don't want. What the expression does is first it defines two variables, width and height, And width is basically how much of the UV space does it take to fill in one cell. So this means how many cells can fit in the UV space? Well, so we get how much UV space do we need for one cell. So this is width, so this is horizontal, and height, which is vertical. Then we calculate which cell do we want to select. So the thing is, let me break this up. If this was laid out on just a very long texture, so all of these faces were here, and there was just one axis involved in selecting which one, that would be simple. But we have two axes because we can have columns and rows and not just columns. So, by the way, designing these faces in Inkscape was really fun. I love the new stuff, especially the power stroke effect, which allows you to do things like, change the width of the path. It's really cool, really awesome stuff. Inkscape is excellent. If you need some vector graphics, learn Inkscape. It's just fantastic. So we're selecting a value of 0 for the cell. This should be for cell 0. Then cell 1, 2, 3, 4, you see? And now we need to somehow determine that, oh, cell 4 isn't here, cell 4 is here. How do we do that? Well, we calculate the remainder of which cell we want. We want cell 4, right? But we have 0, 1, 2, 3. So the highest number we can fit in the row is 3. So we calculate the remainder of division of 4 with 3. So we are left with 1. So we use the horizontal coordinate as 1. So position X is 1. But okay, now we just completely removed the vertical. Okay, we're now we'll be snapping back and forth. Increasing the values will make us loop back and forth, so we actually don't go out of the usable space. But how do we reach the lower rows? Well, then we do a division and we see how many times does the number of how many times does the horizontal amount of cells fit in the index that we want to access. So now it fits 0 times, still 0. Now you would say it fits 1 time, but there is no remainder. Yeah, it fits 1 time, but there is no remainder. So we stay where we are. But now the index fits 1 time, but there is a remainder. So this 1 time that it fits, we use it as a vertical position. So now we're moving here. So our index fits 1 time in the horizontal axis, still fits 1 time, but we have a remainder that grows. Now it fits 2 times, right? Our index is 0, 1, 2, 3, 4, 5, 6, 7, 8. And our number is, the highest number at each row is 3. So we're fitting 2 times in the row. So that means our vertical coordinate is shifted 2 times down. So now we're ending up here. This is basically what the code does. So you see we're calculating the modulus. So the remainder, what is left if you fit, if you cut out the amount of horizontal cells that we can fit. So, okay, yeah, I just explained that. These float and int functions are used to ensure a correct data type for processing so that the calculations can work. The shading language is extremely picky about data types. If, for example, you do this, it breaks because this is an integer number and I'm using it in a calculation to create a float number. But this is a floating point number. So that's okay. You see, yeah, shader code is extremely picky about data types. Sometimes you can say that, well, NVIDIA cards sometimes don't really care. Okay, what did I do? Did I break something? Oh yeah, I did. I pasted. Yep. Now we're back. Right, so this little piece of code then constructs the final coordinates. So it takes this, how much of the UV in X position do we need for each cell? Because, yeah. And then this is what we use. So this is the width of our segment. And then we offset it by the position using the width. So this is how we access from left to right. And this is doing the same up and down. So this is how much vertically we need for one cell. And we offset that by the number of cells we need to shift down position Y. And our UV is the vector that will feed out. And this gives us the, I'm middle clicking to scroll the canvas and I'm pasting stuff. And this gives us the final coordinates of our face. So we can change the face expression here with a number. And now we'll go to the next row. And it works. And the 7th one is empty. Yeah, so basically we can access any face expression we want inside the shader with a simple number. So then that gets composited on top of the team color, which is selected using this. We are either team 0, which is nothing, or team 1, which is, I guess, plum, and team 2, which is lime. I wonder if naming the teams plum and lime is going to be a good idea, because both words are 4 letters long, and that's funny. Okay. Oh, this isn't even used. Oh, this is, by the way, this is a procedural circle texture that creates this nice cutout for us. Otherwise, this face would be square. And as much as that might look funny, it doesn't really work for me. Okay, so now in the character script, we need to somehow change the faces. So I made a method called setFaceExpression. Here it is. So we take an expression, and I've defined an enum for this. So I've defined an enum here, and I'm giving each expression a name. So I'm calling this one neutral. Oh, no. Yeah, so I'm calling the first one neutral. I'm calling the second one attack. So this is what's going to happen if you're going to be, I know, shooting or maybe hitting other people. This is called hurt. So when you get hurt, so other people are hitting you. Next is dead. So this is when you're dead. Next is kill. I think that may be a phase to do when you kill someone, I guess. And after that is lose. I thought this phase maybe would work for, you know, when you lose a match and all your teammates are just running around with this expression. And the last one is for winning, which I thought this could be a nice phase for. I mean, I made some of these phases and then I was thinking, where could I use them? There's one more spot left. If you have an idea you would like to try and design a face and fit it in here, like, get in touch. All right, so this is how the faces are set. I have an expression. I'm also having a tween, and I'm defining a tween that is globally accessible. And that's important because, why did I insert a breakpoint here? So I've specified this face expression tween variable, and I'm just specifying that it's going to be a type tween. And in the setFaceExpression function or method, I am first checking if the face expression tween exists. And if it exists and it's playing, it's running a tweening, then I'm killing that because we don't want that. And why does a tween exist at all? Well, it's because if I want to set a face, I usually want to set it temporarily. Oh my goodness, they all get new expression. Yeah, so let's reload. So when I hit someone, okay, they are hurt, but then I want this face to reset to default. So I don't want them to look hurt forever, right? Or until something else happens. I want them to look hurt until they are not hurt anymore. So that needs a way to automatically like go back to what was said before. Oh wait, where is Godot? And I'm doing that with a tween. So when you're setting a face, you can first choose which face, and then you can set an expiration time. By default, it's 1.90 seconds. No, 1.5 seconds. So once we set the face, which is just here, first we check if the expiration time is more than 0, as 0 is a special number that will mean do not automatically reset this face. And that's useful for example, when we die. When you die, your face stays dead forever unless you respawn, which means your face goes back to neutral and also stays there because there is no point in resetting neutral back to neutral anyway. It will be just wasting resources. So to reset the face, how do we do this? I'm using this predetermined, like globally available face expression tween variable, which I just defined. It has no value. I just defined its type. So when I try to assign something else than a tween to it, it's gonna throw an error and let me know. That's useful. I'm creating a new tween. What I'm doing next is I'm adding a interval. And that means the tween is just gonna wait for however many seconds we put here, which is the expiration time. And after that, after it waits this time, it's gonna tween a property. So it's gonna change a property. And now this is usually used to interpolate things smoothly, but we just want to snap a value back to something. Also, how do you interpolate a string value? Like, okay, no, we're not interpolating a string value. We're interpolating an integer value, but we don't want the expressions to sweep. I mean, we could do that. If I set the duration for this tween to 2 seconds, for example, now if I, okay, get back to game. Now if I shoot somebody, I need to reload first. If I shoot somebody, they're gonna go through other faces in between, right? Because the index of the face, we were on this face, but then interpolating the value of the index of the face, we were going through this. So I don't want that. I don't want the faces to like go through different stages, because that's like the order of these faces doesn't have any meaning. This is not an animation. It's just a sprite sheet for different values I want to do. So setting this lerp duration, or lerp, sorry, tweening duration to 0 means it's gonna happen instantaneously. So I'm setting the face expression. Maybe I should do this to be more like explicit. Cursive expression dot neutral. So now it's pretty clear what we're doing. So maybe I'll break this into a new line. Is this gonna work? Or let's try. Yeah, it works. Yeah, so we're snapping the face back to neutral after this interval. So tweens by default, when you're adding different tweens to it, like you go your tweener and then tween something, that's going to happen in a sequence, but you can also do it in parallel. If you run this, that will set the following tweens as parallel. So if I did that, that would mean it would be waiting in one thread, but also setting this in another thread, basically making my waiting pointless. But, you know, you can create very complex animations and sequences and timed sequences using these tweeners. And I think this is excellent because you don't need to whip out an animation player and create an animation, which may be very hard to parameterize with, you know, numbers, different things. And using tweens, you can build very, very awesome things. And I'm using these a lot, and they have been overhauled from Godot 3. In Godot 4, they are much more powerful and much easier to use, I think. And finally, once we've defined our sequence, I'm just running face expression tween.play, which starts the sequence. But if this is already playing, well, we would have a problem because the tween would exist. So maybe I'm actually overwriting it. But then, yeah, if I have something that doesn't, like, if I like changed my face to heart with an expiration date time of, you know, 5 seconds, but before that 5 seconds happens, I set my face to something else with expiration time of 0. If I didn't check here if the tween is running first and stop it, that means I would set my new face that should have stayed forever, but it would be flipped back to something else because the tween would still be running in the background and it would just do it. So that's why I need to kill it. And the only way to kill it is to keep a reference, because I could just, you know, instead of using a predetermined variable name, a global variable, I can just do this. And this is then a local variable. And the tweener is going to keep running, but I can never go back and do anything with this exact instance of the tween object. And I need to go back and kill it sometimes. Yep. So that's the faces. Let's talk about some other things. And some other things are the outlines. As you can see, I've changed the look of the outlines. They're no longer soft and they're thinner. And what's more, they stay roughly the same width from far away as they are from up close. They also stay the same width if you zoom in with the camera. And believe me, that wasn't automatic. I had to manually create these behaviors. Maybe I'm not going to go into too much detail. What happens with the is it the head? Where's the body model? Here is the body model. Okay. What's going on with a team overlay is it is a material overlay. So it's drawn on top of the basic materials that are there. That means I can have different materials underneath and it doesn't interfere. It just draws them on top as a second pass. And it's using a shader, which is the team overlay shader. And the team overlay shader, I do all the shaders in Visual Shader because I love Visual Shader. Unless I need some code, but then I make expressions and use that together. So here we just have a selection of the color, nothing fancy. Pretty much. And here we're just discarding front faces so that we only draw the back face. And here you can see how does the outline look, you know, without any code correcting it. So first it disappears. When you zoom in, it's too big. But there's more problems. So in the vertex shader, what I'm doing is I'm normalizing the width based on the screen resolution or screen size so that it stays consistent. I'm also taking the vertex, taking the normals, and this is actually not needed. I'm offsetting the vertices along their normals. So basically I'm doing this grow operation. making a shell out of that so it sticks out. And this is also not needed because yeah, these are things I was trying to do in the shader and decided I can't do it in the shader, or at least I don't know how to, so I'm going to do it in a script. And this is where the script comes in. So camera distance and FOV-based corrections is a method I have devised. Is that a right word? To fix that stuff. So first I'm checking for the current camera in the viewport. So get viewport, get camera 3D. This returns the currently used camera object, no matter what it is. Every 3D viewport needs to have an active 3D camera. So actually I could skip this because there has to be one. Otherwise, or maybe there hasn't. I don't know. It doesn't hurt to like make some fail safes. So first I'm calculating the distance between the player character and the camera. I'm also checking the field of view of the camera. And then I'm calculating the thickness of the outline. And I interpolate the distance so that when you're up close, the outline gets actually thinner, is thinned, so that it looks like it's the same width, and you get far away, it gets thicker and thicker to still maintain the consistent width in pixels on screen. And I'm using lerp float method to do that. So at distance, I'm taking into account the distance by 50. So that basically means that at the distance of 50 units from the camera, the thickness is 96. And when you're at 1, it's like, or 0, it's like at 4. So that's a huge difference. And then I'm multiplying this by the FOV. So I'm correcting for field of view, because otherwise, okay, maybe I should turn this off. I'm gonna just, do that and see what happens. So now you see we're not correcting thickness based on the camera distance. So the outline is tiny. Of course, it should be a little bit bigger. So yeah, so this is like, okay, that's a nice, this is where I started. Like, okay, that's a nice width of the outline. But when I go far away, it's invisible. But I can correct it by interpolating it between using the distance. I'm going to comment out the rest of that. Okay, so now we have our outline distance corrected. So you can see now the outline pops back in, even though I'm far away. And you can go far, far, far away, and it's still visible. And it's still pretty okay. But if I zoom in, you can see that it's a bit thick. Now I'm going. So if I zoom in, it stays as thick as it is. I mean, it's not corrected. And I'm trying it to achieve something that it's the outline is a stable amount of pixels wide on the screen. It's not perfectly achievable, but I try to reach that goal. And this is not. So when we're zooming in, these characters' outlines are thick. But we can correct that if we just multiply this using so we can reduce it to 10% width if the FOV is too small. And if the FOV is exactly, the camera FOV is exactly the same as the profile, which is the default one where we should use in the wide view, then it's at 1. And this makes it so that when I zoom in, now when I zoom in, the outline stays of the same width on my screen. You see, it's no longer thick. It's still thin. This makes the outline still look like it's not part of the game world. It's more like something in your heads-up display, you know? Same with the bot badge and the character name. These aren't physical objects in the game world. These are things that exist just to tell you something. And with the banners, which is what I call these icons and names, there was also an issue in that, yeah, let's do that. So we skip this code for now, and I'm going to show you what was the problem. So when I was testing this, like, oh, okay, nice, nice. Whoa, what the heck? So you see, when you're changing the field of view of the camera, the sprites, the sprite 3D and the label 3D, they get huge, even though they are set to fixed size. You can check this here. The badge one, for example. It's set to, where is it? Fixed size. There it is, right? If it's not fixed size, then when you zoom out or you go further away, it's smaller. You go closer, it's bigger, right? It behaves like a physical object. With fixed size, it's always the same size on screen, but it doesn't compensate for the camera field of view. So I had to use the same trick I've done for the outline to scale down the banner items. And I've done this with a loop because, so I'm going over all the children of the banner node. And the banner node is a parent of all these elements. So this is that. You see, first I tried, okay, let's scale down the banner. But when that happens, when you scale down the banner, what happens is everything is shrunk towards the origin of the banner node, which is at the feet of the character. So that doesn't work. Okay, but maybe I can change the scale of every single one of these. Okay, that seems to work better. Yeah, okay. So I went ahead and I went through all of the scales of these, and I'm doing the same thing as I did before. I'm dividing the field of view, the current field of view of the camera, by the target or default field of view, so that when we are not zoomed in, this returns 1. And I'm not multiplying the vector 3.1 because otherwise I would just get a float, and this accepts a vector because there are 3 dimensions for the scale because it's a 3-dimensional object. So I'm getting a 3-dimensional vector here, and this one just gives me x, y, and z values of 1. So this is a vector 3, 1, 1, 1, and I'm multiplying it by 2 to make it 1, 1, 1, or 0.5, 0.5, 0.5, etc. And final thing that I did when I was looking at this is, let me show you another thing. No, undo. Yep, let's comment this out. So the thing is like, oh, why they are invisible? Oh, maybe I touched something. I probably touched something. I'm gonna just reload the game. It's gonna be quicker. Yeah, so I may have moved the objects in the source scene and it updated in the instances, but it updates with global coordinates. So it's not offset. I turn off the menu background for now because it doesn't need to be there. Yeah, I have some issues with the camera. So when I first start, I'm looking for the eyes of a bot and I need to hit C a couple times to get back to my player. So the problem was, okay, you can see that these banners disappear. They fade out, right? It's just to, one thing is it's there to not clutter the screen too much. Because if you would see this for every single player, at any distance, it would be pretty useless. Too much information. But also, you know, there's the part of fiction in there. Like, you're far away, you can't see the details of the character. You get closer, you realize that they are a bot, and their name is bot1, right? But when we zoom in, that should also come back together, right? We should be able to see these from far away, and we couldn't. So originally it was like this. Okay, we're still good. So you zoom in and you see nothing. I mean, you don't see the banners. And I was like, oh, that makes no sense. You should be able to see the banners from far away if you're zooming in. That's the point of zooming in, right? To see more. I mean, so I added the interpolation of the distance fade values so that you can't see the banners from far away now. Actually, you can see them from 4 times as far as you could see them before, because the zoom is 4 times. So now, even though I'm here, I can still kind of faintly see the banners of them. Which makes sense. I think that's cool. Oh, and one more thing. Now there's a banner that shows that you're zoomed in. I'm not super sure that these binoculars are well drawn. If you can come up with a better design, let me know. I'll be happy to get some help. So when someone is using zoom, you're going to see these binoculars above their head. You can see, you know that they are zoomed in and they can't see what's around them very well. So that could be an occasion to shoot them, you know, or sneak up on them. So yeah, that's pretty much everything I wanted to show you today. There's a lot of work ahead of us, but we're doing some nice progress. Okay. Thank you so much for watching. I hope to see you soon in another development update of the Liblast project. Bye.